All right, guys, so in this video, we're going to be taking some notes on scientific notation. What? Science and math? No way. Yes way. Science and math go hand in hand, and scientific notation is a mathematical topic that's used often in science. To give a couple examples of when it would be used in science, I have a couple measurements on the side of the screen. The first is the distance to the sun. The sun is about 92,960,000 miles from Earth. Pretty big number there. And then below that, I have the radius of a nucleus, one of the smallest cell structures known to man. And that's 0.1418. FM is the measurement on that, and that's femtometers. It's a really, really tiny measurement. So for scientists, thinking about how busy their days are, they don't want to be spending their time writing out every single one of these zeros every single time they need to discuss the radius of a nucleus. So what we have is scientific notation. Scientific notation, filling this in on page 21 of your note packets, scientific notation is used to write really big, like the distance to the sun, and really small numbers, kind of like the radius of the nucleus. So as you can see here, 6.23 times 10 to the fifth. That's a shortened way of writing a really big number. 10 to the fifth, if you were to type this into your calculator, 10 to the fifth is going to be 100,000. 10 to the fifth power, 10 times itself 5 times is 100,000. We're multiplying that by 6.23. So as you can imagine, this is the same as 623,000. Scientific notation is a compact way of writing that large number. And so the 6.23 is what we call a coefficient. We've seen that word before. Coefficient means the number we're multiplying by. And then 10 to the fifth is a power of 10. Powers of 10 is how we do our number system. We have tens place, we have the hundreds place, we have the thousands place, the 10,000s place, the 100,000s place. Those are all powers of 10. And we multiply the two together. We multiply the coefficient by whatever the power of 10 is to give us the number that we're using. So two different ways that we could be writing this. We could be writing it in scientific notation and trying to go to standard form. Standard form just means the number written normally. So we always use the exponent to tell us how many places we need to move the decimal point. So I'm going to write down 1.56, the coefficient, and then I'm going to use the exponent of 4 to tell me how many places to move my decimal point. So I need to move it 4 places. 1, 2, 3, 4. And so my decimal point is now here. Anytime you have a blank space, you're going to put a 0. So 1.56 times 10 to the fourth is the same as 15,600. And so over here, we just have to make a quick correction. We should be moving to the right when we have a positive exponent, and we should be moving to the left when we have a negative exponent. So since this was a positive exponent, when I moved my decimal point, I moved it to the right. Had it been negative, we're going to be moving it to the left. And then we can go from standard form to scientific notation. So what we want to do is we want to drop our decimal point where it belongs. Decimal point belongs right there. And we want to count how many times do I need to move it to get a number that's between 1 and 10. So I move it here, 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 here. If I were to just drop the decimal point right here, that would give me 24.07. That's not a number between 1 and 10. So I got to go one more place to get 2.407, which is a number between 1 and 10. So that's going to be my coefficient. And I'm going to count how many times did I move my decimal place. I moved it once, twice, 3 times, 4, 5, 6 times. So I raised 10 to the power of 6. That's a 6 right there. All right, so we moved the decimal point 6 times, so the exponent should be 6. All right, so the first part, we want to circle the examples that are correctly written in scientific notation. To be correctly written in scientific notation, I need my coefficient, and you should write this on the side of your paper, to be between 1 and 10, and I need a power of 10. So look through. Take a second on your own to try to circle the ones that you think are correctly written. All right, so looking through, this first one right here, 6.2 times 10 to the 8th, has a coefficient between 1 and 10, and it has a power of 10. So this is correctly written in scientific notation. 13.8 times 10 to the 5th, well, 13.8 is not between 1 and 10, so that is not correctly written in scientific notation. 1.29 times 10 to the 5th satisfies both our criteria. 7 times 10 to the 9th works. 9.01 times 10 to the 4th works. 5.407 times 20 to the 6th doesn't work because we can't have a power of 20. We need to have a power of 10. And then this one is not going to work because it's not a number between a coefficient between 1 and 10. So down here in the box, you need to explain why we crossed out the 3 problems that we did, or the 3 numbers that we did. Okay, in part 2, we're going to be writing the numbers in scientific notation. So the first one, I always write down my coefficient to start. So I write down 7.1. Since my exponent is positive, anytime you have a positive exponent, and you should write this down on the side of your paper, means that it's a big number. A negative exponent doesn't mean that it's a negative number, it just means that it's a really small number, like the size of a nucleus. So I wrote down my coefficient, and since my exponent is 3, I need to move my decimal 3 to the right. So I move 1, 2, 3 spaces. Anywhere there's a blank spot, I'm going to fill it in with zeros. So 7.1 times 10 to the 3rd is 7,100. For the next one, I write down my coefficient, 6.04. And since my exponent's negative, I'm going to be moving my decimal to the left because I'm trying to make a really, really small decimal number. So I'm going to move 1, 2, 3, 4, 5 places, my decimal point. Everywhere that I have a blank space, I'm going to put a 0. So I get 0.0000604. I want you to try numbers 3 and 4 on your own. And then to write the number in scientific notation, we're going to drop the decimal point where it belongs. When it's a really big number, it belongs at the end of the number. So I'm going to move this until I get a number between 1 and 10. So I'm moving it once, twice, 3, 4, 5 times to get 7.31. That's a number between 1 and 10. And since I moved it 5 places, my exponent is going to be 5. Positive 5 because it's a big number. Then for 6, I need to move my decimal point 1, 2, 3, 4 places to get a number between 1 and 10. So I get 5.8. Since I moved it 4 times, my exponent needs to be 4. Since my number was a small decimal, it should be -4. Anytime it's a small decimal, we have a negative power. I want you to try number 7 and 8 now. So pause the video, and when you unpause it, wait for the answers to 3, 4, 7, and 8. All right, so here are the answers to 3, 4, 7, and 8.